Hi, this is Christopher, CMO for Finxact and host of xtnsbl podcast. I'm really excited about the conversation we'll be having today with Tom Eck, who is SVP and CIO of Digital Transformation at Fiserv. And we're going to be covering what's certainly a trending topic. Tom, just before we get underway, maybe you would tell us a little bit about what you've been up to just in terms of your career and then maybe a little bit more specifically about what you're doing at Fiserv today and in this area, I think would be interesting.
Sure, would love to. And thank you for having me join this. I'm very excited. I've been asked to be given a lot of talks about this, and maybe you'll understand why. My undergrad was chemistry, so the plan was med school, kind of following my dad's footprints. And it was tough, right? I kind of really had a struggle to get decent grades. But then when I got to senior year, I had some electives that I could take. And now this is, I will date myself. So to put this in context, this is in the late 80s. So at my school, my undergrad was Boston College, there were not many AI classes, right? There was I think there was one on a programming language that I don't think is used much anymore called Prolog. That got me very interested. And I took a few more of those classes. And to me, it was just easy. And I'm like, man, I've been busting my, chops over the last 3 years on chemistry. This seems like what I should be doing. So after that, I went and kind of got my first master's was in comp sci. And the very first class, it was an AI related class. And the professor said something that was slightly not true, but it caught my attention. So he presented the most simple unit of a neural network. And a neural network is what's really behind most of what we think about today as AI. There's other disciplines, but we're going to focus on neural networks. So he kind of showed us the most simple neural network possible. And the thing that hooked me was he said, and no one really understands why this works. So I love emergent behaviors. So I was hooked. And I've gone on and done things in lots of different industries. Probably the last 13, 14 years I've been in financial services, but some more of my graduate school work was related to drug development. And, I used a lot of machine learning and AI techniques in that. So basically, I have been involved in one form or another with AI for the last 30 years or so.
Yeah, I've been following your work. It's a fascinating, just sort of academic formation that ultimately somehow brought you to financial services. But I think doing what you love and at a super exciting time, which is what we'll be talking about today. So now at Fiserv, in the position you're in, and we will be talking today about the acceleration of the safe and responsible use of AI, and you have a lot to do with that for us. But could you talk a little bit about what that responsibility and what that role looks like today for you at Fiserv?
Yeah. So over the summer, my boss, Guy Shrella, who's the COO of Fiserv, we were having a discussion about AI, and he goes, we're at a state right now where it's, his words, organized chaos. Right? And kind of what he was saying is that there's a bunch of, I don't know what we want to call them, mavericks or just curious people that started digging into AI and started producing some things already, which he thought is great, and I do too. But I'm not a big governance person. I'm by trade a software engineer. I like building stuff. But I kind of realized if we don't get all these other things right besides the technology, we could end up in a bad spot. So what I mean by that is we have to take into consideration things like legal, ethics, data privacy, all these kind of different disciplines, risk, compliance, all that. Bring that all into the fold. So it's like a 7-legged stool, and one of the legs is the technology. So I figured the genie is escaping out of the bottle. The sooner we can, control it, the better. But I purposely use the word accelerating, the safe and responsible use of AI, because this is not meant to govern in kind of you're allowed to do this kind of application or this kind of application. It's more about we're going to put guardrails in place to the extent that we can so that you can't stub your toe as a developer, right? So you don't have to worry about, coming up with your own set of privacy policies, et cetera, et cetera. We're going to do it once firm-wide and then go at it, right? So federated model, but I just wanted to solve for those kind of non-technical parts, once. I'm sure, laws will come into play, things will have to change, but I thought it was very important that we get in front of that.
Yeah, I do too. And I'm really glad that Guy was already thinking along those lines. So, just for our audience, a little bit of a preview of what we're going to be talking about over the next short while. I'm hoping maybe, Tom, you could just start off with a few sort of, definitionally, we've been sort of introduced to a number of terms, some of them kind of sounding similar, not meaning exactly the same thing. But AI, academics, scientists, industry experts have been at it for decades, really. But some important things have happened very recently.
Yeah.
And I think we went, probably late 2022 to start to get exposed to the term generative AI. And then that's kind of pointing in the direction of AGI. And what is that? And so helping us a little bit understand the distinction. And then also, I would like to cover just some of the milestones that sort of got us to this point. But the thrust, I think, or I hope, of our conversation can be about how do you see this manifesting in financial services? How might it change the creation, the delivery, the consumption of financial services? So looking forward to this conversation. Thanks again. And just to jump right in, maybe start with that. As I said, this didn't happen overnight. A lot of things led up to it. What do you see perhaps as some of the key milestones that got us to where we are right now?
Yeah. So, let's look at ChatGPT first, right? T's meteoric rise was absolutely astounding. Had 100 million users in 2 months. And if you look at the adoption rate of that versus even something like TikTok, still blew it away. Mm-hmm. It took Netflix 7 years to get to that level. So it seems like it was, an overnight success, right? And ChatGPT just had its 1-year anniversary. So tongue in cheek, I posted on LinkedIn, happy birthday to ChatGPT. You're 1 year old, you're 1 year old, and you've only been gestating for the last 80 years. So, and again, that's tongue in cheek, but the very first chatbot ever built was in the 1950s. So this is not an overnight success. This is more like standing on the shoulders of giants and building on that, right? Now, what's interesting, when you look at the history of AI, there were a number of, let's call them peaks and valleys. And like about 3 or 4 times, depending on how you define the term, we had what were called AI winters. And what an AI winter was kind of like a next level discovery was made and was overhyped. Mm-hmm. And then it disappointed, wasn't able to do what it was promoted to do. It advanced the state of the art, but it couldn't live up to these like hyperbolic claims that were being made about it. So then people lost interest. And then you kind of, researchers went on to other things. But thankfully, we had some that soldiered on. And then a new advancement would come. It would also disappoint. We go into another winter. I would say the golden age of AI really started, I would say, in probably 2015 type of era, maybe 2013. And what were the advancements there that kind of propelled us to where we are now? Right now, this is where the advancements and the number of researchers, the number of papers published, you could plot all that. It went hyperbolic. So there was a couple of things that happened, right? One is hardware. So GPUs are graphical processing units. Everyone has one in their computer. And, gamers who play video games on their PCs or whatever spend a lot of money on super high-end graphics cards, GPUs. Now, why is that? And the reason for that is because when you're rendering, let's say, a video game screen, there's many, 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 many floating point operations that have to happen. And to make them happen most efficiently, you can do them in parallel. So instead of like computing each little pixel, you have like a lot of little pieces of this graphical processing unit, each processing a piece of the screen. So then some researchers in the AI community realized, well, the way we're headed with these kind of next generation of neural networks is we also need to do lots of floating point math, and we love to parallelize it. And so somebody's like, well, why don't we look at using GPUs? And if you look at the stock price performance of NVIDIA, who's one of the major producers, you can see what that led to and how that was adopted. And funny like anecdote about this right now is we have a severe GPU shortage. The big, AI providers can't get their hands on these things fast enough. So now they're all going to start building their own. Anyway, so that was a major advancement in being able to build larger models. So around that time, we discovered that bigger is better. And I'll come back to this later. Okay. So in order to build bigger neural networks, you needed more of this hardware. The second thing was, as you build a larger neural network, you need to provide more data. And the reason for that is that if you have a very, very large neural network and a small amount of data, it will just memorize the data. It won't be able to do what our generative AI architectures are doing nowadays, right? It's just more like a lookup of a knowledge base if you just memorized, right? You couldn't ask it to do something that it hadn't seen before. It cannot extrapolate. So the second thing that really kind of launched this new era was just the availability of data on the internet, right? So these models in this kind of era kind of sucked up everything they could on the internet. Now, that's good and bad. So it could be fake news, right? It could be editorials with somebody's opinion. It could be biased, all these things. But the race was on to build bigger. And what's also interesting is that the entire corpus of what humankind has produced, at least in text, can fit on a 45 gigabyte USB drive, which I think is interesting. And I'll leave one more final anecdote on that one. That the mystery of what happened recently with Sam Altman, who was the CEO over at OpenAI, the board fired him. He went to Microsoft for about half a day, and then he came back. So there's a bunch of theories as to what happened, and the one that I kind of subscribe to is that Sam and team hit on a way to get around this problem of limited data and actually using another AI to generate synthetic data, essentially being able to create an infinite amount of training data. So that's just kind of a side note, just to put kind of, current events in context. Okay, so we talked about the hardware and we talked about the data, but the real advancement was a paper published by Google researchers in 2017, and it was called "Attention is All You Need." Mm-hmm. And that was, pun intended, transformational, because that's the paper that introduced this new neural network architecture called the transformer. And that was 2017, and all of these things kind of came together. And at that point, since, I would say from 2017 to maybe 2020, the race was, I need to get as many GPUs as possible. I need to get as much data as possible. And I'm going to use the transformer architecture. So that's then the cloud providers, big tech, let's call them, really, it became a race to build the biggest. And out of that, obviously, ChatGPT was born. GPT, by the way, stands for Generative Pre-trained Transformer. So it's a transformer that's been pre-trained. And when we say training, by the way, of a neural network, what we're saying is you basically are feeding the neural network examples. So I'll give a very simple one. You could build a neural network to detect whether an image is a cat or a dog. So the way you do that is you give the neural network an image of a cat and a label. This is a cat. And then you do the same thing for dogs. And you do that over and over and over and over. And the neural network actually learns how to detect. It's a classification problem, right? Is this a dog or is this a cat? So if you think about the training of a neural network, that also increases, I think, quadratically with the size of the network. So what that ends up being is you need to invest millions of dollars, many millions, maybe 60, 80 million dollars to build some of these first foundational models that have come out in the last few years. But I think we'll talk a bit later about how that's kind of changed.
Yeah, so that's really helpful to frame it that way. The hardware had to get to a certain point. There had to be a certain quantity of data so that it wasn't just memorization. It was getting closer to sort of synthesizing and mapping relationships. And that's what really happened when the transformer architecture was published. Exactly. So if you don't mind, go right at that. And if it needs to be a technical definition, allow it to be. Folks, if they don't want to hear it, they can change the channel. But it was a seminal paper. It is a moment in time. And I think it would be cool just to hear you try to help us understand what's going on in there. How are all of these pieces of technology, whether it's, natural language processing, machine learning, coming together to help this come into being?
Yeah. So I think it was around 2013 that I also believe this came out of Google. There was an approach or an architecture called BERT. And what BERT was good at doing was what we'd call sequence to sequence tasks. Translation, language translation is probably the most popular one, right? So I input a sentence in English and I want the output in Portuguese, for example. So these models were trained basically to understand the similarity between different words. So it was trained on huge corpus of text, and it would ultimately understand what the concept of, and I'm going to use a very famous kind of analogy here, talking about it could understand what a king is, what a queen is, what a monarch is, what a man is, what a woman is. And this is where kind of one of the core parts of the transformer was introduced. So very important to this whole concept, even of the GPT models, is what we call an embedding. And an embedding is let's call it a numerical representation of an arbitrary sequence of text. Okay. So basically, when you're training the network, it is figuring out how to take a sentence or one word and generate an embedding. Now, the way that I think about an embedding is that it's a point in space, but a very, very high dimensional space. So if you can, of course, we can't really see these things, but if you can imagine a space that has 500 dimensions, okay, the embedding would have 500 floating point numbers in it. And to me, I think about that as that's a point in some 500 space. So the word king sits over here somewhere. The word queen is over here. And then what's interesting is that the word man is much closer to king in this space than it is to queen. Mm. And then you can do some interesting mathematical operations. And you could say like king minus man plus woman. And actually, like mathematically, it'll point to queen. So this kind of started this whole idea. The algorithm was called word to vec, actually, that was underneath that. So taking a word and generating this vector of floating point numbers. Okay, so building upon that, some 5, 6, 7 years later, that's really what the transformer architecture is, just on steroids, really. So a transformer has two components, an encoder and a decoder, okay? So the encoder, let's go back to this language translation task, right? So the encoder knows how to take the English string and generate an embedding for it. And that's the key thing. So between the encoder and the decoder, there's this mysteriousness in here, which I don't think anybody fully understands why it works as well as it does, but that's where these embeddings are. So English sentence come in, an embedding gets created, the encoder's now done. Now it's time for the decoder. So now the decoder takes this internal representation, this vector in 500 dimensional space, and its job is to decode that into the output that's being requested. That's what's happening now. The other thing about it is they're kind of self-referential. So if you ever go on ChatGPT, like on the website, you'll notice that it returns like a word at a time or a few words, then there's a little pause and then a few more words. There's a reason for that. It's because we call that autoregressive. So what happens is the first word gets output by the decoder. So let's say I'm just trying to do a generative task. We call this a completion. I'm going to give it the task, instead of being a translation task, is I'm going to start something and I want you to finish it. So I'm going to give you several words and I want you to complete this sentence or whatever. So yep. Yeah, the prompt, right. So let's say I told it my input was Mary had right? Mary had I feed that into the transformer, and the decoder is going to come up with a probability distribution of what the next word should be. How does it know what that distribution is? That's what it's been trained on, and that's kind of what's in this vector space, okay? So the decoder will output just the next word. So I gave it, Mary had and it'll put out, I don't know if I said little or not, but it'll say little. And now it'll loop back again and say, okay, now complete this phrase. Mary had a little. And by this point, it's going to be super confident that the next word to output is lamb, right?
Interesting.
So, yeah. So that's why it's autoregressive. And that's kind of why you see kind of these spurts of the response coming back, because it's doing it one token at a time.
Let's now double click a little bit into those prompts. So you're talking about sort of the prompts that are given to the encoders and how the embedded layer is created. And it makes me think about sort of that old adage, good data in, good data out. It seems like there was a period of time, you described it maybe in the early stages of AI, where just the more data, the better, just like feed it the whole internet.
Right.
Whereas now there's more emphasis on the quality of the data, which I don't know, maybe there's pros and cons to that because there's not as much, but there's, perhaps there's more reliable data, there's less bias. Just talk for a minute about, is that in fact happening, and what's the reason for it?
Yeah, you're spot on. So this race to build the biggest model, which required the most amount of data that was not curated, that's over. And what people have been finding, and by the way, what's really interesting that's also driven all this is open source. So when you look at a company like Hugging Face, great company, I love what they're doing. They're making advancements in AI very approachable to many researchers and practitioners. And it's going to be interesting to see how that whole thing plays out. Open source versus closed source proprietary. So some of these open source projects started asking the question, is bigger better? So just to give you an idea, okay, well, there's a term you probably will hear about called parameters. So when we talk about the size of a neural network, a transformer model, whatever, again, a neural network is a synthetic representation of neurons, right? So you have a neuron and it has connections to other neurons, right? And the strength of those connections in artificial neural networks, that's called a weight. So given these two neurons that are connected, how much influence does this one have on this one? That's a weight. Each one of those weights is a parameter, okay? And there's some other parameters too, but just to put it in context. So some of these largest models have approached 1 trillion with a T parameters. Absolutely, absolutely massive, right? So I believe that the open source community started looking at, do we really need all that? And they started trimming things down. And now what we're seeing are models that are coming out that are very performant. And instead of being, 1 trillion parameters, they're now on the order of 7 billion. These things can run on your phone just about. We're getting to that point, okay? Now, what's the other side effect of that, right? Remember I said before, the bigger the network, the more data you need, okay? So the smaller the network, the less data you need. So what's now the trend that's going on, which I think is very good, is smaller but curated data sets. And I'll give you an example, like IBM Watson X, they have a model called Granite, and it's completely curated. It was trained on a completely curated data set, and you get much better results, and it eliminates or greatly reduces the likelihood of giving a biased answer or fake news or something like that. So very much a step in the right direction. Very interested to see how small these models can go and still be so performant.
So how do you see that, I guess, sort of that last mile, if you will, like this hardware kind of mashed up with the data, with the transformer architecture is producing, an output. And, whether image, whether text, whatever sort of form that takes. If we're now going to sort of take our discussion into how are we going to accelerate the responsible use of AI and commercialize it and make customer experiences better, specifically in financial services, how does an API endpoint interact with what comes out of that model and extend it into a, potentially a Fiserv application that's doing some good out there?
Yeah. So,
and any examples if you already have some in mind?
Yeah, sure. But first I want to just say, and I'm stealing Microsoft's term here, these models are co-pilots. And I tell everybody this, you are still the pilot. I think these models can get you about 80% of the way there, which is a great productivity lift, right? No doubt. But you can't rely on them yet. I would not put them in front of a customer unless you are extremely confident. There's been some very public fails where one of them was an attorney, I guess was maybe, I don't want to say lazy, maybe didn't think this through, but had to write some kind of position letter or something to a judge. And the story goes, he used ChatGPT, did not check in the document that the GPT model produced. it referenced other cases, 2 other cases that were similar to this one that he was talking about. Those cases did not exist. They were completely fabricated by the model. And obviously, you could think of the personal brand hit to his personal brand reputation.
Mhm.
So we got to be really careful about that. All these models, whether they're generating code or they're summarizing a document or any generating anything, you need to be cautious. We're not there yet. And I may as well discuss what we call those are hallucinations. And the problem with a hallucination, so in other words, a hallucination is when basically the GPT model generates fake news or whatever, fake, like I just said, these fake cases of law. One of the insidious problems, it's these models always, can I say, their tone is always very confident.
Authoritative, yes.
Right. They're very convincing
Right.
and well written, all that kind of stuff. How do you know what is a so-called hallucination and what is ground truth? So that is a active area of research. There are, if we talk about building your own chatbot, which by the way is really the number one area that we're focusing at Fiserv, and I'll tell you why. And this is what I'd recommend to your viewers, your listeners, is a chatbot trained, and I'm using the word trained very loosely here, on your content. So in other words, it could be product documentation.
Mhm.
It could be everything about HR that maybe a new hire would want to be able to just ask questions of. By providing your own data and using a technique that's called RAG, so retrieval augmented generation, this greatly reduces the hallucination problem
Mhm.
and is basically what I would say most enterprises are that's how they're, getting their toe in the water. And the reason these work so well is because it's a 2-step process. And this goes back to what I talked about before about embeddings. So the way this works is you write some code, and it's not a lot of code anymore. And by the way, it's Python. If you want to do any meaningful research or, applying transformers or any form of actually machine learning or AI, you better know Python. So that's one point there. It's not a lot of lines of Python. So what you do, it's 2 steps. So the first step is you get your repository of data. That's the hardest part, as always. You need to get your own curated data set. Again, garbage in, garbage out. So let's assume that one of the chatbots I recently built is for one of our processing platforms, and it's a series of PDFs, and they're probably like 80 to 100 pages each, kind of a legacy approach to documenting. And so you write some code that looks at each PDF file and breaks it up into chunks. Each one of those chunks, then you ask one of these GPT models to generate an embedding. So basically, you can give it a paragraph and you get back this list of, let's say, 500 floating point numbers. You give it the next paragraph, you get another list of 500. Again, these are points in this space. Okay, so now, once it's kind of been trained in this manner, you can start asking questions. So what happens is the user inputs a question. How do I get started with my 401k? Let's say it's the HR bot or something like that. So what you end up doing is you end up creating an embedding for that question. And then you look in this space for the nearest neighbors. In other words, which document fragments are nearest to this question. And you take those nearest neighbors. And by the way, this is a art as much as a science. Like, how many do you take? And how do you ascertain whether, this one is better than this one? Still research. But ultimately, you take all those fragments of your inputs and feed it into a GPT model along with the prompt. And this is where kind of prompt engineering has become very important. So you don't just give the data and the question directly to GPT. You first set basically a context. So typically we say something like this. We say, you are, and we're talking to the GPT, right? You are an expert in HR. You've been trained on all of the, let's say, Fiserv policies and all that kind of stuff. I want you to answer respectfully. And if you don't know the answer, so here's some tricks that were discovered, right? Somebody discovered if you use this phrase, you'll get a much better result. If you don't know the answer based on this data that I'm giving you, say, I don't know. Do not make up an answer and do not use any data that you were already trained on. So we're just leveraging the model for its understanding of the semantics of language. But we're providing the actual content to it. And we're using them internally first. That's another really important thing. Because again, it's still, to me, it's still a co-pilot. So this is something that somebody working HR support might have access to this tool internally and, listen to the question from, whoever called in. They use this tool, which could help them, with the response and not have to comb through pages and pages of a website, for example.
Yeah, it sounds like a better place for that experimentation to start, sort of mid-office, back office. And I believe you performed a similar experiment in your lab with a subset of the Finxact documentation.
Yes.
And you trained a GTP model on just, being able to ask a bot a question about, how do I create a ladder CD? And just quickly getting to the relevant information about how that's done. I thought that was really slick.
I'll tell you why that works so well is because your documentation was really good.
Yeah, it is really good, but there's lots of it. And so I can certainly see how getting to the point where you have a co-pilot like that, that can help you on your way could be very helpful.
Yeah, for sure.
This has been super. You know what? With the little time we have left, I wish you would just talk to us a little bit about, there's an important initiative going on at Fiserv, which is the whole sort of hub and governance and structure that you referenced a little bit earlier, that you and team have created to explore this carefully, successfully, to accelerate it. Maybe just describe that a bit.
Yeah, so we are organizing ourselves like a couple different groups, I guess, within this acceleration hub, right? So we have a steering committee, which is really kind of the executive sponsors, and then there's a governance. And I really don't like the word governance because it just slows things down. And by the way, all my colleagues are shocked that me of all people is the person that brought this up, but others were already thinking about it. So I'm really just kind of trying to connect all the work that's been in flight already. We also just did a survey across the whole firm about ideas or, from each business unit, how do you see AI could be applied, in your business unit? We did a survey. We're kind of compiling the results. And then we're going to, so then there's this governance, and then there's kind of like let's call it the technical leadership that's actually going to, build and deploy these things. It's definitely going to be a federated model. I just want to get the policies set and blessed by, legal and risk and all that. And, again, to the degree that I can codify it, meaning a developer who maybe is, just kind of getting into this AI space, I want them to be able to innovate and build and not be in fear that they're going to do something bad or end up on some kind of naughty list or something like that. And so we really just kicked this off in earnest. Again, there's been work going on. AI is not new to Fiserv, by the way. We've been using it in our call centers. We've been using it for fraud for many, many years, right? But I think it's this new age of AI that caught everybody's attention because of ChatGPT. AI has kind of come to the fore again. And our clients are asking us, what are you doing with AI? About AI? How are you thinking about applying it? And when I first started getting these questions from, some of our large bank clients, I could sense the tone, and I would put it in two categories. So some of the asks were just not just curious, but they wanted to make sure that their partner, Fiserv, is on the front foot, right? And we are going to be taking advantage of these advances, which is going to help you and your end customers. But I think the other camp, in other words, the other kind of tone that I intuited from the requests was more fear-based. What are you going to be using AI for? Are you going to be using it to make underwriting decisions? So I think it's very important that we get these policies right and get, first internally. And then I would advise my boss that we should send a letter out to our clients, on the topic of generative and other forms of AI, the way we're approaching it in a very responsible way, and how we're going to be using it and how we'd like to partner with you on helping you get going.
Yeah, clearly. I love it. Just, that Fiserv's doing it and very, very proactively, very transparently. As you can see, we're, here talking about it, and just very much sort of a front foot posture. And I don't want to just like throw a grenade here at the end, but I guess a slightly provocative question, because as you said, there are camps. And I'd like to hear from people who are really close to a subject matter and get their opinion on it. Is generative AI, is AGI, is it going to eat the world or is it going to save it?
So AGI is artificial general intelligence. It's something that was, it's at the core of movies like Terminator and Skynet and those things. But the last I've seen on this topic is that some other researchers just looked at kind of the state-of-the-art models like GPT. I think it's GPT-4 Turbo now. And I have to pull up the paper, but the way they plotted it in terms of like intelligence, humans are up here and the models are still way the heck down here. Now, if you talk to a neuroscientist, they'll tell you, and I'm not a neuroscientist, but there's like 5 areas of the brain or 6, or I forget what they are. These models are only modeling one of those. Like, they're not compassionate. They're not even good at reasoning, right? They're just good, right? These generative models are just good at predicting the next word.
Okay, so this is not yet the singularity.
No, and I'm certainly not a fearmonger, and I'm not afraid. I'm usually not afraid ever that the sky is going to fall. I don't think the machines are going to harm us. I think it's people using the machines are the real problem. The other metaphor I use is like, this is the discovery of, the power of the atom, E equals MC squared. It's been used for a lot of really good things, and it's been used in war. So I think that's where kind of the governance at the government level, and we see, the EU just put out some law last week. I think that's important to do because we have to somehow have control over how these very, very powerful models are being used. So I think that's where the concern lies. And I'll leave you with one more thing. I give these talks a lot, and we didn't really get into the developer productivity part, but that the whole developer space, software engineering space is changed. I mean, it is changed. If you don't know how to use something like GitHub Copilot, whoever else does is going to take your job. So it's not a question of, is AI going to take your job? It's more like somebody who's really good at applying it might be, if you don't. So that's where I think we're headed. And I think models are going to continue to get smaller. And what we learned about GPT-4 is not just one massive model. It's 8 separate GPT 3.5 models. So they call that a mixture of experts. And I think that's the direction we're going to be heading in. Smaller models that are really good at specific domains kind of coming together to, in a seamless way to look like, an intelligence.
With fewer hallucinations.
Fewer hallucinations. We've got to solve that problem.
Well, hey, this has been just a fascinating topic and conversation. Really appreciate you very much sharing your time.
It's been my pleasure.
Thanks, Tom.
Thank you.